Good morning. Welcome to our second session of the Data Science Festival Main Stage 2022. See, slip back in time through the lockdown. Our talks from Alastair, Magda and Ray of Attest. They're going to be talking about empowering growth without guesswork through data science. Alastair's part of the core team at Attest. He's bridging the gap between production and development, building the data analytics platform there. And before Attest, he worked across marketing, logistics and defence sectors, consulting on data science. Magda's been working on natural language processing for the past 4 years, looking at integrating external and internal text databases to help generate the insights they need for market research. And she's particularly fascinated by natural language generation and developments in that area. And Ray has been a data scientist for about 10 years. She's now a senior data scientist at Attest. And she's really enjoys looking for patterns in data, building the models, and answering the questions that actually drive business decisions. She's also particularly interested in diversity in data science. She's currently a mentor for Tupu, and she's done previous roles, for example, at the TrueCure Woman in Health Data Hackathon. So, over to Ray.
Cool, thank you. So today we'll, hi, okay, back to the beginning. So today we're gonna talk about what data science does in Attest. So there would be 3 of us talking today. I'll talk about what is Attest, what we do at Attest, and what are the challenges we face. Magda then will come and talk about some NLP-specific algorithms that we design in our product. And then Alastair, our data engineer, will be talking about how we deploy it and how we keep it going. So, a quick overview of Attest. We are a London-based tech scale-up in market research. At the moment, we have 164 employees. 69 of them are in R&D. We have offices in both London and New York, and we have recently raised Series B funding. We're looking to grow to 250 employees by 2023. And at the moment, the ML team has 5 data scientists and 2 data engineers. We're looking into hiring 2 more data scientists and 2 data engineers. We've got a booth number 4, so if you're interested to know about this more, please come out and meet us there. So Attest has got its own product. Therefore, we have a set of clients. We work with large enterprises and businesses to small startups. So on the right, you can see the list of some of our clients, some of which you might recognize, like Boots, EE. We also work with the smaller startups like Made by Nachos, which is a cat food brand. So, on the right, you can see Attest product is a survey platform which connects more than 125 million consumers around 58 different countries. And what it does, it provides a fast, easy, and a scalable way of asking consumers questions and getting their answers and analyzing them. So how does data science work generally in Attest? We are working in a Spotify model of squads. So data scientists don't work there on their own. They're embedded inside something called a squad. In each squad, not only you have data scientists, but you have product people, design people, software engineers, which could be front end and back end. So on the right, you can see the first 3 rows is some of our squads, example of our squads, and the projects that data scientists are involved in. But apart from contributing to data science in squads, we also work outside of our squads on projects which are interested for the business between data scientists and data engineers. So This was a quick recap of what Attest was and that it has its own product and its own survey platform. Now we want to discuss some of the challenges we face and how data science helps to solve those. In the past, market research was used to run surveys in person or by basically making phone calls. But at the moment, because it's much faster and cheaper, surveys are run online. But the problem is, when you run surveys online, it has some inconvenience. One of them is that the people who are responding to the survey might not necessarily be attentive, so they might not pay attention to the survey. Also, one of the other problems is something called click farm or bot farm, which is the image you see on the right, which their idea is to collect money, because when people respond to a survey, they receive money. So bot farms are basically a way to get more money, and they're not giving genuine answers to the survey. And we need to detect this type of behavior. So throughout this presentation, we might use a term called taker or respondent, and both of them means somebody who is trying to answer a specific survey. So we said that some takers have bad behaviors. I'm going to give you 2 examples to make it clear what we mean, and then we're going to talk about how we detect them. So one of them is contradiction answers in this example. You can see the question is, which of these statements do you associate with Vodafone? And one taker has picked both is cheaper and is more expensive, and this is not possible. The other one that you might see is getting gibberish or irrelevant text answers. So the question is, what activewear brands have you purchased in the past 12 months? And you can see the answers. Some of them are just random, and some of them are very good quality product, which is irrelevant, and we need to detect this type of answers. The reason we need to detect them is that bad behavior can bias the results of the survey, and it's very important to remove them from the analysis. So how do we deal with such behaviors at Attest? One of them is that you need to bear in mind that not all takers are giving bad quality answers because it's intentional, but actually they might just not be attentive enough throughout the survey. So one of the things we try to focus on is to use something called behavioral nudges. And I'm going to talk about this in the next few slides. But even though we try to nudge the takers, we still see bad quality responses, and therefore we need to detect them. And then I'm going to talk about algorithms called quality checks, which solve this problem. Okay, so we talked about nudging the taker to give good answers. What are behavioral nudges? They are basically a picture or a text which comes at the start of the survey. We noticed the importance of this specific implementation through experimentation design. So basically we had one control group, a survey with no nudge, and then we had 5 different surveys with 5 different nudges, and the idea behind the nudges comes from the book called Thinking Fast and Slow, which might have heard before of. So I'm going to show you what these nudges are. It could be a picture. The system one is basically this one, the picture of a watchful gaze, or a picture of cloud words. The system two is just sentences describing peer pressure, authority, and morality. We ran this control group and the 5 treatment for 5 days in UK, launched at 3 p.m. We got 200 respondents for each survey. We analyzed that data, and we noticed that the combination of ideomotor and the morality reduced inattention by a significant amount. Okay, This was the behavior nudge. Okay, we've nudged the respondent to give a good answer, but not always that happens. So we need to detect those bad takers, which are like bot form. That's where we introduce something called quality checks. Quality checks are basically algorithms, which can be machine learning models or statistical models that analyze the behavior of a taker. In Attest, we have multiple quality checks. I'm going to quickly give you a few examples for you to realize what we're implementing. One of them is something called the speeders. These are people who fill the survey much faster than they actually should. So they have like that bot type attitude to filling surveys. So if you know or you can estimate the average fill time of a survey and you have a threshold, anything behind that threshold is that specific taker has gone too quick, so they're a speeder, so probably they're not attentive. The other thing is answer quality. This is what I showed you initially about irrelevant answer and gibberish text answers. This is an NLP model. Magda will go into the detail of this specific quality check, and you'll see how it works. The other one is attention checker. This one, we got to know more about it through experimentation design. Basically, is a question at the end of the survey which tells you what to pick. So here it says, could you pick none from the list here? So if a person is not picking none, therefore, they're not an attentive taker. And the last one I'm going to talk about here is overclaimers. These are people who, throughout a survey, if you have a lot of multiple choice questions, they have the tendency to pick all the answers for all the multiple choice questions, or most of them. Okay, as I said, we have much more quality checks in our product, but these are a few of them. How do they work together to make a decision? So once a taker comes in and starts filling out a survey, they go through all the quality checks that we have. Each quality check spits out a label, whether that taker is good or bad. These labels are then fed into a weighted formula, and at the end, we say whether that taker is a good taker or a bad taker. If they're a bad taker, we reject them, and we try to recruit more takers for that specific survey. Okay, in the past few years in Attest, we have collected a lot of data. We have wealth amount of data, and we have started collecting web interaction features. So how the takers act when they open a survey. We have the quality check features, and we have some specific features of the taker and survey. So what we are doing at the moment, we are trying to improve our detection framework. We're building a model using all of these features. We're training a model, and once a new taker comes in, we just build the features for it, fit it into our model, and we get a probability, which then help us to say whether that specific taker was a good one or a bad one. This is much better than what we have at the moment, just because it, first of all, allows us to use more data, and it also helps to find interaction between specific features. Okay, now I'm going to pass to Magda to take you through details of some of the NLP models.
Great. Thank you, Ray. Hi, everyone. My name is Magda. I work as a data scientist in Attest, and my main role is to apply modern natural language processing techniques to our text data. And where does the text data come from in Attest? Well, predominantly, it comes from open text questions in our surveys and the answers that the respondents give to these. And an example of such open text question would be, what is your opinion about our company and why? And the user, the responder, is then left with an empty field to fill in with whatever they please. As you can imagine, such data can be very difficult to analyze and aggregate without automation. So I will show you how we leverage this data with NLP. Firstly, what Ray mentioned before, we encounter a lot of quality challenges with all our responder data. And we built a specific model for open text answer quality check, which is one of the checks that Ray was telling you about in our pipeline. And we developed this model in 2020. This particular model rejects irrelevant or gibberish open text responses. And what do we understand by irrelevant? For example, you have an answer, very good. Very good on its own seems like, reasonably sounding sentence. However, it depends what context of the question is. Here we have a question, who do you normally buy Christmas presents for? And very good would be rejected because it doesn't make sense in the context of this question. Going with the same logic, same answer can be accepted or rejected depending on the question asked. So, for example, to a question, what is the best football team? Liverpool would be a completely accepted answer by the model. Now, on a personal note, you can agree with that decision or not. I personally do. Then, to another question, on the other hand, such as why do you enjoy shopping online? Liverpool would be rejected as an answer. Such question-answer matching is a very widely researched subject in NLP, and the models are usually trained with questions being the input to the models and answers being treated as the ground truth. So the models learn to match answer to the question, or in other words, to understand what answer would be relevant to what question. And then we also have gibberish answers that we want to reject. And by gibberish, we understand anything that is just randomly typed in the keyboard by the user in order to skip through the survey without even reading questions. This is the pipeline to our answer quality model for open text. It consists of two phases, as you can see. The first one is keyword extraction, and I'll go through each single step with you and also explain why we extract keywords at all. And the second phase is the decision model itself. So here we have keyword extraction. First, we have to have some input to our model, and that input in our case is a taker round. And the taker round is the set of questions and answers given by a particular taker, so the responder, for one particular survey. So we have questions from the survey, and we have a set of answers by one single user. Next thing we do in our pipeline, and I will explain later why, is to detect the language of the survey. And by language here, I mean English, German, or Dutch. We use pre-trained Facebook's model, fast text, in order to detect this language. And we could theoretically get this information from the metadata of the survey, but that can consist of some errors, and we want to avoid making the wrong call here. So we pass all the questions to that fast text model, all the questions from this survey, in order to see what language the survey was written in. Now, we do detect this language in order to then use a correct keyword extraction model. Such keyword extraction models are usually trained separately for each language. That's why it's such a crucial information to know. And I'm going to tell you now why we extract keywords and where we extract them from. So firstly, in surveys, you often have something like follow-up questions. And follow-up questions can literally sound like, why did you answer that? Or why did you pick this answer? It is very unfair to expect from our model to be able to make the decision if the answer to that question is relevant or not without knowing the context of the previous answer or previous question. Therefore, we need to pass this context somehow to our model together with the answer to give the context. And passing all the questions from the survey to a model would be really not very performant and very slow. And we decided to extract top 10 keywords from all the questions in a particular survey. We used for that a text trunk model and its implementation in Spacie. So we have this question, these keywords extracted. We pass them together with the question in question and the answer that we want to make the decision for, to reject it or accept it. Our model is based on DistilBERT model. DistilBERT is fast, performant, small, and cheap version of BERT model. And for us, speed is crucial because we need to make this operation in real time. DistilBERT also has the advantage that it works in multiple languages. And as I mentioned before, we often have, well, we have customers around the globe and they fill in surveys in different languages. We trained so we used pre-trained model and we fine-tuned it with our data, which was 1 million open text responses from our previous surveys from the database. And as the grand truth here, we took a manual rejection of the taker from before based on open text question of a kind. And we trained the model in a multi-GPU setup on AWS SageMaker for over 3 days. If the model's decision is to accept the response, we don't argue here and we go with that decision. However, if the model rejects the response, we do still, on top of that, some manual checks. We use regular expressions and rules to extract things that might look to the model like gibberish or irrelevant, even though they are not. And an example of that could be brands. Brands can have very novel, funky names, and the model haven't heard of such name before, so it might look like gibberish. The same can happen with postcodes and zip codes. It would be very difficult to train the model on all of these from around the world. A currency check, if you, for example, type 10 KR, it means 10 crowns, but to the model it would look like gibberish. We do emoji check. We only accept emojis if the emoji was mentioned in the question itself. And we do a numerical check. Often we realize that if the answer is only, consists only of numerical characters, the model finds it irrelevant. So what we covered so far, Ray and myself, is mostly about takers or about responders to our surveys, how we check the quality of their answers. But then what we do with these answers, we present it to our users. So now I'm going to switch the subject slightly and start talking about our users. Also, we can call them clients or we can call them makers, which we do because they are the ones that build or, in other words, make the surveys. So, as you can imagine, analyzing a big amount of open text answers can be a very mundane task. Imagine 300 answers that can be very complex depending on a question asked, and trying to extract information from it and then aggregate this information to have some insights. Surely automation is a very needed thing here. And only recently, we released our beta version of text analysis platform. Exciting times. I'll show you how it looks like briefly. In this case, the question is, what do you like about social media? And on the platform, users can see aggregated key phrases and keywords that are extracted from each single answer. There could be a few keywords and few key phrases in one single answer. And then we give the frequency, how often they were mentioned by responders. We built a word cloud on top of this frequency with the size of the words or phrase depending on how often the key phrase was mentioned. So we have this, but is that really enough? We didn't want to make the users not have the full context. So just giving them key phrases without seeing the whole answers wasn't an option for us. That's why you see these little arrows on the right, and when the user clicks on one of these, they see the list where the phrase was mentioned of the whole answers. There are huge opportunities in our text analysis platform, and one of them is sentiment analysis. We built a model already, and we work on deploying it in production now. We have a few designs. Here, for example, you can see the grouped key phrases, as mentioned before, and the user can be presented with the sentiment aggregated for the whole group. And then we want to give them an option to put the tags that they want. So they will name them, they will choose them, just for them to easily organize the information. We, of course, showed a spread of sentiment across all answers, but then also the user can see the spread of sentiment among the tags that they put. And in this case, the question to the survey was, what do you like or dislike about our restaurant? And the user can clearly see that the atmosphere was liked much more than the menu. And while we were building our sentiment model, we understood that the survey data is much more challenging for sentiment analysis than the data from social media or reviews. And one of the main reasons for that is that models are trained on tweets and reviews. So when you use pre-trained models, you cannot really expect them to perform as well on your data if it's different. Another reason is that the answers are often not very sentiment charged, and this is because the questions are not evoking sentiment. Questions often ask users to describe something, and to just tell a very short particular answer, as in how much do you earn. Another reason is that answers are short, and what that means is they often make no sense without the context of the question. They can be irrelevant or gibberish, or they can have arbitrary meaning, and that means they can have different sentiment depending on the question. For example, to a question, what do you like about our brand? Quality is a perfectly positive answer. But to a question, what could be improved in our products? Quality would be rather negative. I'm not going to tell you now what we've done when we were labeling our data set to deal with these edge cases, but just want to make you aware that this was really difficult and we needed to make some calls and some assumptions. And understanding how unique the survey answers data is was the key to our success. We built a data set from 10,000 survey answers from our database. We split that data set into training, test, and validation. We use the test set to evaluate different models, and we use training and validation to fine-tune pre-trained models for our MVP. In terms of complexity of training, first we evaluated some simple pre-trained lexicon-based models just to have some benchmark. We used TextBlob and Vader, for example. I think we got around 67% of accuracy, again, something we would expect with such difficult data. Then we use pre-trained transformer models to evaluate, and then we fine-tune a chosen transformer model with our data set. And I will tell you now and show you the results for the second and third step, so you will see the difference and what we managed to achieve with our data. So first we evaluated pre-trained Bertweet-based sentiment model. It's a model trained on millions of tweets that is specific to sentiment classification. And with that, we achieved 80% of accuracy. And you can also see that the model is not very balanced. So firstly, 80% from such powerful model is not something you could expect if your data was tweets. I would say it would be at least 90. So that shows how different our data is. Also, as I mentioned before, it didn't do well with neutral class. And then what we did for our, sorry, the clicker is slow. What we did for our MVP is we fine-tuned chosen model, which was Bertrand sentiment, on sentiment task with our data set. And here, we went up 11% in accuracy, and you can also see that model is very well balanced between all the classes. And this is just our MVP. This is the first iteration. In the future, we plan to build bigger data set and retrain the model. So yeah, that's it from me. It was nice talking to you, and I'll pass it to my colleague, Alastair.
Test. Good. Okay, so we've got our model developed. So the next stage of getting this model into production is getting it deployed. Missed the meme. Sorry. So I hope you forgive this 5-year out-of-date meme. If you're a data engineer and you've tried to deploy a model, I'm sure that you can relate. The first time I tried, I was taken to the inner ring of hell. The challenges that you face with deploying a model into production vary on use case. In Attest's case, we are dealing with 125 million people filling in surveys across 58 countries. That means real-time data is flowing all the time. So we have to be able to serve requests, have a model deployed running all the time, real time. What does that mean? It means that our model needs to be fast. Our makers, the maker of the survey, they want to be served quickly. Our takers, as there are so many responses, they need to be, well, analyzed quickly. So is our model fast enough? Can we compute the features in real time? Is the latency sufficient, etc. The next challenge is scalability. As I mentioned, we have 125 million consumers filling in hundreds of surveys, each with thousands of answers. So it needs to be able to scale and be cost effective, because we aren't a bank, unfortunately. So the third part is teamwork. Having come from consulting, this has traditionally been where model deployment has failed most. At Attest, we have resolved this issue by going with a Spotify model, which allows data scientists, data engineers, and product managers to all get involved in the model deployment process and to get feedback quickly if there's an issue with model production, well, model deployment. I feel like the best way to make these challenges come alive is to give you a real example of a model deployment. For the purpose of this, I will use Magda's open text analysis. I feel like this is a good example of, well, it describes well what open text analysis does. So we get a open text response from a respondent. We analyze the themes. Good packaging, nice. Taste disgusting, well, to each your own. And what it does is it sorts them into separate themes and sentiments. If you imagine thousands of these responses coming in, it'll obviously be like packaging, maybe 100 responses, taste, 50, etc., with the interface that Magda showed previously. So we're getting these responses in real time, but our makers will be taking the survey at a different time later. So how do we actually design the system to work? Well, I give you our logical flow, and yes, the text is large enough. Okay, it can be split into two components. The orange component, which is the taker side of the survey, where the survey responses come in, and the green flow, where the maker interacts with our platform and receives the response. So how does this work? Exactly like shown. So a response comes in, lands into our magical backend, goes to Kafka, and goes into our deployed machine learning model. Our model takes out the key phrases and we index it in Elasticsearch, a nice quick query database. Brilliant, it's in. The next stage is our maker clicked a button on the text analysis dashboard, click run text analysis. This sends an API call to our magical backend, which then says our maker wants to run text analysis on this question. And what it does is it queries OpenSearch. It says, okay, give me the themes and groups and answers for this question. OpenSearch responds, gives it to the nice answer grouping service, goes into the back end, and front end make it look pretty. Right, brilliant. But the challenge is, how do we actually coordinate this? If it was a batch process, we would use something like Airflow or Prefect or Luigi, and workflow orchestrator. But with real-time workflow orchestration, there's a bit of a challenge. And to solve that, I have a magical plankton called Benthos. And it really is a magical plankton. So what is Benthos? It is fancy real-time stream processing made, well, mundanely simple, which is absolutely brilliant for a data engineer like me. What that means is we have a executable, which can be deployed on any platform in a Docker container, just running on your PC. You say, okay, I've got some real-time data coming from this source. I need to enrich it, restructure the data, put it through some if-else statements, and based on these conditions, send it to this output. And it does its job absolutely perfectly. So, brilliant. We've got an orchestrator, but now we've actually got to make the magic happen. And I give you our phenomenal architecture with 2 planktons. So the way it works, starting from the taker side of the equation, the taker responses come into Kafka. They feed into Benthos, which does schema validation. Is it a legit response or is it a Kafka tombstone event? We also do, well, that's mostly it actually. Then it goes into the key phrase extraction model. We've deployed it with MLflow for easy deployability across environments, and it also allows us to change the model with ease. So our deployment method will not be compromised. The next stage is data enrichment. So we've got a response from our deployed MLflow service. We now need to structure it nicely so it can land in OpenSearch. And the magical plankton does it for us. And if anything breaks any component of that pipeline, it goes to the dead letter queue, where we decide how to bury it or fix it. Right. The next part is the maker interacts with the front-end API. And it's literally just an API call, like URL / group answers question ID this. And it sends the details to OpenSearch. OpenSearch comes back to the fast API deployed service. The reason we use fast API is because it's extremely fast and therefore suitable for our needs of speed. Need for speed. Ooh. Okay, so this is brilliant. We have solved our speed issue. We've solved our scalability issue because all hail Kubernetes, the mother of all scaling. So what do we have to do now? I think we'll have to monitor the model. So we've deployed it, but to be a responsible data engineer, once you have it in production, you must monitor the model and you must monitor the entire pipeline. To do this, we use Prometheus and Grafana. So at every stage of the data pipeline, we're aggregating metrics. We're making sure inflow equals outflow. We're checking the latency. We're checking where messages are going. And at any point, if something goes wrong, we have alerting to send us a Slack message and to send us to despair. So, brilliant. Well, I say brilliant because no one else says it to me. Okay, so, right, we've got it deployed. It's monitored. Fantastic. What now? Well, I've got some bad news, guys. It's the end of the presentation. But if you would like, we're not taking questions, unfortunately, but should you like to discuss anything further, be it NLP, data pipelines, what we're like at Attest, or even French pastries, croissants in particular, just come and find us at booth number 4. And we have a lot of merch, and yeah, thank you for having us.